So this is for Power Standard 3. We are looking at classifying shapes, specifically triangles and quadrilaterals. Triangles have 3 sides, quadrilaterals have 4 sides. So as we talk about classifying types of triangles, we have a set of classifications that are based on side length. So we have equilateral, isosceles, and scalene. An equilateral triangle has 3 equal sides. So the distance or the side length of each of these sides is going to be the same, okay? All the same length. So maybe they're all 5 inches, okay? An isosceles triangle has 2 equal sides. So this side and this side will be the same length. Maybe both of these are 6. And the other side could be something like 10. Just any other number that's not 6. And then a scalene triangle has no equal sides. Each side has a different length. So maybe this side is 3, this side is 4, and this side is 5 for the length. All right. We can also classify triangles based on their angle measures. So an acute triangle, regardless of side length, has 3 angles less than 90 degrees. A right triangle has 1 90-degree angle. It has 1 right angle. In an obtuse triangle, 1 angle is going to be greater than 90 degrees. So this angle right here, if this was a right angle right here, it is greater than that right angle. It's going to be more than 90 degrees. So if we wanted to look at these angle measures on a graph, okay, so for this triangle, these grid lines on my graph, they always form 90-degree angles all the time. Grid lines always form 90-degree angles. So if I wanted to determine quickly from a graph perspective if I had a right angle, an acute angle, or an obtuse angle, I could look at these grid lines. This grid line right here forms a 90-degree angle. So pink is my grid lines. Then if I switched colors to something else, green I'm going to signify as angle A, okay? Now this green line is less than 90 degrees. It is less than those pink grid lines that I drew. Same thing for angle B down here. Again, I have my grid lines, and then in another color, I will mark the lines of my triangle. So right here would be angle B. It is less than the grid lines, meaning that it is an acute angle again. Now let's say we had a triangle. We had a triangle like this. Imagine that those lines are really nice and straight. Okay, again, here's my grid line, okay? And the angle of my triangle, maybe this is angle F. Here is my angle on the triangle. Notice that it is greater than the pink grid lines. So this would be an obtuse angle. Okay, let's go back to that first document and we'll go through. These are types of quadrilaterals, so 4 sides. So we have a parallelogram, okay? Opposite sides are equal and parallel. Equal meaning that they're both going to be the same length. Maybe each of these side lengths are 10, and these side lengths are also equal, just with a different number. So maybe these ones are 8. And opposite angles will be equal as well. Okay, so this angle will be congruent to this angle, and this angle will be congruent to this angle. For a rectangle, again, opposite sides are equal and parallel. So this side and this side, let's say these sides are both 12 inches. And this side length and this side length are each maybe 6 inches. Okay, they're both equal on the opposite sides. And all angles, this part's different, all angles are going to be right angles. They're all going to be 90 degrees. All right, moving on, for a square, opposite sides are parallel. All sides are equal. So each one of these sides, maybe they're all 4 inches. So we'll label all of them as 4. And all angles are right angles. So all of these are 90 degrees. And then for a rhombus, opposite sides are parallel. All sides are equal. So maybe they're all going to be 3 inches. And opposite angles are equal. We don't need to worry about that last one. We're not going to deal with that in Math 1. All angles, or opposite angles, are equal. So instead of a square where they are all right angles, opposite angles will be congruent, kind of like in our parallelogram. All right, so that wraps up classifying shapes.